Okay, we're recording. I'm going to talk about complementary angles for a little while. Actually, I'll zoom in. Here we go. Here's my triangle. I'm going to make it in a rather peculiar shape so we can see what I'm doing here. Let's just do that there. There's my right angle, so it's in standard form. There's theta, and this angle here is 90 minus theta. We talked about that. These are complementary angles. And so what I'm going to do is I'm going to relabel my sides. I'm going to call them X and Y and Z, just because I can. So now we're armed with a whole bunch of trig ratios. So what I'm going to do is figure out what sine theta is. Well, sine theta is opposite over hypotenuse, which in this case is X over Z. Now what I want to do on this side of the graph is to work out what the sine of actually, I'm going to work out what the cosine of 90 minus theta is. I don't know what that is. So I want to work out the cosine of this angle here. So, as I keep on saying, the thing to do is to rotate it around and reflect it so that this angle here is at the lower left and the right angle's there. So I'm going to do that, and you'll see what I'm doing here. It's like that. There's my right angle. This one is 90 minus theta. So this angle here is the angle I want to take the cosine of, which is this one here. That's theta. Now let's label these sides. The hypotenuse is Z. This one's Y here. This long one here is Y, and this one here is X. So on this diagram on the right hand side, in fact I'm going to get rid of that one there so you can't even see it. This diagram on the right hand side, cosine of 90 minus theta is always adjacent over hypotenuse, which equals, it's the adjacent angle to this, the adjacent side to this angle here. So it's X over Z. Right. Now we observe that that's the same as that. It's basically because the sides have swapped identity. If we're considering this angle here, this X here is the adjacent, whereas here X was the opposite, because here X is opposite that angle there. And this Y is the opposite to this angle, but it's adjacent to this angle here. So we've got this nice little thing here, and it's true in general, that sine theta equals the cosine of 90 minus theta. How about that? So that saves an enormous amount of time. If I've figured out the sine of an angle and then I want to work out the cosine of 90 minus that angle, then I've just got this nice little relationship here. Just a minute. Right, I've got my calculator here. So I'm going to verify that. Every time you see a result like this, I'm going to verify it for you, or I'm going to demonstrate that it's true. I'll go back to black. Here we go. So I'll say theta equals, let's say, 17 degrees. So I'm claiming that sine theta equals cos of 90 minus theta, where theta equals 17 degrees. So I'm saying that sine 17 equals cos of 90 minus 17, which equals the cosine of 73 degrees. So I'm saying that sine 17 equals cosine of 73. Well, let's try that. Let's figure out what these are with my calculator, and then we'll see. Oops. And then we'll see what happens. Okay, so here's calculator. We'll look at this one first. 17 degrees sine. All these decimal places, I'll only record the first three, 0.292. 0.292. Well, we better figure out cosine of 73 degrees now. Okay, dunk. 73 cos 0.292. I just want to make it clear that what I've just done is not a mathematical proof, it's just a plausibility argument. All I've done is use the calculator just to check that we've got it right. And of course, if this number had come out differently, I'd have screwed up my algebra somewhere. Okay, so we've got this nice little finding that the sine of 17, or the sine of any angle, is equal to the cosine of its complement, which is quite nice. I'm going to stop there.